Resultant vectors. In this video, we'll be talking about examples, real-time examples that we can meet in an examination. So stay tuned. Let's continue. Number one, if PQ is equal to negative 1, 3 and RQ is equal to negative 5, 8, find PR. Now, in our previous video, we talked about resultant vectors and we established the fact that if a vector PQ is added to another vector QR, the answer gives us PR. So meaning that this alphabet over here, which is a Q, if it ends this one, the next one that is supposed to be added to, that Q should begin it. But in this question, you can identify that they didn't give us QR, but they gave us RQ. But then in the same previous video, we talked that this one can be given to us when we negate this one. So it means that if the vector is moving from R to Q, to get the QR we are looking for, we have to negate this one so that to give us the inverse of that. To get QR out of this RQ, we have to negate the RQ. Negating this means we're going to use negative 1 to multiply this vector over here. So the PQ is constant. We've been given PQ. So it's negative 1, 3. That is what you stated here. Now we can see that PQ plus QR is equal to PR. But then QR is equal to negative RQ. The QR wasn't given to us. That is what we are looking for. So QR that we are looking for is equal to negative RQ, which was given to us in the question, which is negative 1, negative 5, negative 8. So we use negative 1, that is a negative over here, to multiply the vector. So negative 1 times negative 5 gives us positive 5. And the negative 1 times negative 8 gives us positive 8. So we add this PQ, which is the negative 1, negative 1, 3, sorry, to the new QR we found, which is positive 5, positive 8. So negative 1 plus 5 gives us 4. And then positive 3 plus positive 8 gives us 11. So this is the answer for this question. So if you are given a question, it's not always that you will get whatever is in this equation over here in the question. Sometimes they can turn this and make it QP. You will have to find PQ. Alright, before we continue with the second question, at the end of this video, we'll be having a take-home question. So I'll give you the question. It's over here. When we are done, you solve this and you let me know the answer in the comments below. And then we can see where we'll go from there. Now the second question. In this question, everything has been given to us directly. If you can study it, you can see that everything has been given to us directly. So the AB is negative 1, negative 3, and BC is negative 2, 4. So we are supposed to find AC, and in the equation, we can say that AB plus BC is equal to AC, meaning that AB here, the B ending this one begins this one. We established this fact in the previous video, so if you've not checked it out, please go and check it on resultant vectors. So this B here that ends this vector AB begins at the second vector BC. So we have AC. We are supposed to find this. So all we need to do is to substitute the value for these vectors inside. So AB is negative 1, negative 3. That is what we have here. And BC is negative 2, 4. That is what we have here. So we are supposed to find AC. Now our AC is equal to negative 1 plus negative 2. That is the negative 1 here plus the negative 2 here. And then negative 3 plus 4. That is the negative 3 plus 4. So if we compute this, we are going to get AC to be negative 3, positive 1. So this is the answer for this question. Now let's move to the take home and let's end this video. Now the take home, this is the question. If BC is equal to 610 and DC is equal to negative 4, negative 5, find BD. The second question is, we have this vector here. Please watch where the arrows are pointing. This one is pointing this way. This one is pointing this way. This one is pointing this way. These directions of the arrows are the ones we write on top of these vectors. So you look at where it's pointing, then you solve it. So QR here is this, and this part is this one, and this part is question mark, question mark. So you are supposed to find QS, that is this one right here. So solve this and let me know the answer in the comments below. Thanks for watching this video and come back soon.